Welcome. In the early embryo there is a cavity, the intraembryonic coelomic cavity. This cavity develops into cavities around the heart, the lungs and the intestines, respectively the pericardial, pleural and peritoneal cavities. These cavities in turn are lined by membranes, respectively the pericardium, the pleura and the peritoneum. Collectively they are known as serous membranes. Serous membranes are slippery membranes that line the inside of the body cavities and cover the organs that are embedded in these cavities. Hence the heart, the lungs and the intestines are all lined by these serous membranes. The serous membranes allow the ensheathed organs to move in relation to their surroundings, whilst they also partially fix the position of the organs. The serous membrane of the gut is the peritoneum. In this video we'll explain the general relation between these serous membranes and the organs they surround, especially the relation between the peritoneum and the gut. The relation of the serous membranes to the ensheathed organs is traditionally explained via a balloon model. Even though it's probably not 100% correct from a biological development point of view, it provides a conceptually easy to understand model, which is why we'll demonstrate this balloon model here. Imagine we originally have a completely empty abdominal cavity. The spleen is still in place in this model because we can't remove it here, but you should imagine it's also gone. Now I'm going to introduce the peritoneum. This balloon stands for the peritoneum. Inside the balloon stands for the peritoneal cavity. Imagine that the balloon, that's the peritoneum, is completely blown up, and I'll place it in the abdomen, and thus it fills the complete abdomen from inside, and thus the peritoneum lines the inside of the body wall. Now I'll introduce the gut. This white tube stands for the gut. The gut is in fact behind the peritoneum in the abdomen. Now I'm going to take both the gut and the peritoneum out to demonstrate you what happens. And I'm going to turn it a little bit. The gut gets, over time, embryologically, gets pushed into the peritoneum, and in that way there's a layer of peritoneum that comes to lie adjacent to the gut. This layer that you might be able to see here. That's the so-called visceral layer, named after the word viscous, that means intestine. Now remember that this peritoneum was also in the abdomen, so we also had a layer on the outside, adjacent to the body wall. That's called the parietal layer, called from the Latin word parius, which means wall. Now, in fact, these two layers were lying adjacent to each other because there's no air in the peritoneum, in fact, like there's in this balloon, but there's only a slightly bit of slippery fluid. And the balloon is completely filled with convoluted and long intestines. These intestines have pushed into the balloon like this. And because it's completely filled with these intestines, the layer that lies on the intestine, the visceral layer, lies directly adjacent to the layer that's on the outside, the parietal layer, and with only this little bit of slippery fluid in between, these layers can move in relation to each other, and that means that this organ, in this case the gut, can move in relation to its surroundings. And that's the great thing of this configuration, that it allows organs to move into to its surroundings, in relation to its surroundings. And that's so far about this model. So far this model. We can schematically draw the balloon model with this cross-section. Once again we see the gut, the visceral and the parietal peritoneum. And the gut was pushed into the balloon in this direction. Imagine the gut now being pushed even deeper into the balloon, such that the sides of the balloon collided again behind the gut, thus forming a double layer. Such a double layer is called a mesentery. By definition, a mesentery is a double layer of peritoneum that arose by invagination of an organ, and that connects the organ with the body wall, and that gives pathway for neurovascular structures from the body wall to the organ. The great thing about this construction is that the gut can move freely, but at the same time there are limits to its freedom because it's fixed to the back wall, so the chances of getting entangled are slim. The second great thing is that the blood vessels, the lymphatic vessels and the nerves can reach the gut, as they have a pathway through the mesentery. Summarizing, we discussed that the heart, the lungs and the intestines are surrounded by the pericardial, pleural and peritoneal cavities. And these cavities may be viewed as a balloon into which the heart, the lungs and the intestine have been pushed from the outside. And the balloon material, representing respectively the pericardium, the pleura and the peritoneum, thus gets adhered on one side to the organs and on the other side to the body wall. And these sides can slide over each other, thus enabling movement of the embedded organs.